Hello and welcome to another one of D's ADD videos. Today we're going to be looking at the disk and washer method. Two methods that you can use to find the volume. So as I said, if I'm rotating a 2D object about a fixed axis, you're going to create a 3D object and it's going to have a volume. So we can use the inner function of the 2D object and it's going to coincide. If the inner function coincides with the axis of rotation and there's no hole, you're going to be using the disk method. If there is a hole and they don't coincide or it's curve function, then you're going to be using the washer method. So let's see that in action. Here's a 2D object, y equals x, probably one of the first functions you learned, if not the first. And it's a 45-degree line going through the origin. And if we were to rotate it about the x-axis, otherwise known as y equals 0, you get this three-dimensional blue shape. All right? This has a volume. You should be able to find that volume using the disk method formula. So the volume for the disk method is going to be pi times the integral of alpha to beta, that's just where you're going to start and stop, of t of x squared. And t of x is just some arbitrary function in which you're going to take the outer function, okay, in this case it would be y equals x, right, forming the outer boundary of your 3D object. Usually with a rotation about the x-axis, that's going to be your top function, okay. The outer function, if I were rotated about the y-axis, would be the one on the right, okay. So you take the top function minus the bottom function. So two-dimensionally, if we're rotating about the x-axis, you can see that the bottom function would be y equals 0, creating that triangle looking shape right there. And when you rotate it, you get, there's your triangle 2D, but then it becomes a 3D object. So you can find the volume again by using this formula. T of x is just the top function or outer function minus the inner function of your 3D object. Now what happens if we have a hole? Let's say our function curves right here, or we rotate it about an axis that's, or our axis of rotation is different from our inner function. That's when you use the washer method. You'll get the hang of this if you practice enough, as always. The key to learning any of this material is to just be humble and practice, practice, practice. When you get tired of practicing, practice some more. And then you'll see it's not as bad as you thought. Most of it was all in your head. Check out the example videos for further clarification. You can pause the video, try the problem, and then check the solution. If you get it right, cool, move on. But if not, go check my work and compare your work and see where you went astray. All right, thanks for watching. Have a great day.